Swayam Prabha. Digital India. Educated India.
Welcome to the course Environmental Impact Assessment. In the previous class, you had seen we started with the process in detail, and we had looked at this very briefly before also. So today we're going to look at the second box here from the image, and here we'll look at the prediction of impacts. So this is one of the very important part of EIA, and the entire core lies here. So for this purpose, we are going to look at it to certain detail, and our key reference for this particular section is chapter 5 from the book Introduction to Environmental Impact Assessment by Glasson and Therivel. So prediction is a key part of EIA process, and if you look at EIA, primarily it is the prediction part. And you will see that this prediction is not just a linear process, but you go backward and forward, and then you keep improving the process. So we are going to look at this impact prediction part, the process part of it. The methods and other things we'll look at it later in the methods section. So accordingly, our coverage would include that we'll look at different dimensions of predictions. We'll look at what are the methods and models of prediction. We'll just look at it in a very umbrella term. We'll not get into the details. When we deal with the methods section, there will look domain-wise different methods and models which are available for prediction purpose. We'll just take a very generalized view here. So further we'll look at the uncertainty which is involved in prediction, because we are predicting, and prediction is always uncertain. There is certain level of uncertainty which is involved, and we'll look at how do we what kind of data sources are used for forecasting purpose. So accordingly, the learning outcomes would be that after completion of this, you should be able to identify different dimensions of predictions. You should be able to name them, you should be able to identify them, and then you should be able to generally review or synthesize the overall methods and models which are used for prediction purpose, and then you should be able to discuss various uncertainties which are there in EIA process in the prediction component, and then you should be able to identify and discuss on various kind of data sources which are used for the prediction purpose. Now moving on to the prediction part, we first see how to predict the impact, what methods and models will be used in the prediction. In this section, we will look at various aspects of prediction, we will look at how to predict the impact, what methods and models will be used in prediction. We would be learning how to look at the limitation of any prediction methods as well. So looking at the dimensions of prediction, what do we really to predict. So the purpose of any prediction is to identify the magnitude, to what extent the impact will happen with or without the proposed project, what is really going to happen, what kind of impact will happen, and to what extent will it happen. And we look at it from the perspective of when the project comes, as well as when what will happen irrespective of the project. So through the prediction, we also try to determine the significance as well, what will be the significance of that particular impact. So what is the first step you undertake in the prediction? The first step of prediction is that you look at the legislation, what is required in the country you are in and what kind of law requirements are there. So when you're given an assignment to undertake a prediction, then first thing which you'll do is to look at the legislation of that particular region, country you're working in, and what kind of laws you have to abide by, and what kind of prediction requirements you might have to do. So that would be the starting point. So you will be referring to all the range of legislation, guidelines, standards, and all of these we have already discussed in past few weeks about domain-wise all different legislations which might be applicable at the local level, regional level, country level, or at the like how you would be aligning your things with the convention as well. So based on that, you would prepare a list of indicators and check what kind of changes are likely to happen. So prediction involves the identification of potential change in indicators of relevant environmental factors, like you look into the biophysical, socioeconomic, and all these factors. So the prediction involves like what kind of really change is going to happen. So you can see here we see air quality standards and water quality standard from CPCB as an example. So based on that, you would really see like is the change going to be beyond these range which are given. So that is how you really check. So you saw impact in the first initial stage of EIA process as well. So there you tried to identify which impact to consider and look at a broader category of impact concerning with the project. So when you remember and look at the first box which we saw, so if we were also identifying impacts there, but that we were doing to narrow down to really see what kind of impacts would happen. But at this stage we'll actually calculate or undertake the impact prediction. So in prediction process, you try to identify, and you try to identify what? You try to identify direct and indirect impact, like you can you can have, we have talked about the range of impacts, if you recollect that, what was direct impact and what was indirect impact. Like direct impact is like having air pollution, and then air pollution leading to health problems, which would be air pollution would be direct impact and health problem would be indirect impact. So you try to identify all those problems concerning with your project. So for this you can use very simple cause and effect diagrams to indicate like really what kind of things are happening. Then you see to what geographical extent the impact will take place, whether whatever impact is happening, that air pollution, will it be just like few meters from the sites, or it would be at the regional level, or the pollution can be at the national level or at the international level. So what level, whatever impact is going to happen, how far would the geographical extent would be. So we'll be looking at that. Then whether the impact are beneficial or adverse, whether they are positive or negative, you're going to look at that aspect. And then you would be also required to look at the duration of the impact, like how will the duration be short term or whether the duration will be long term, whether it will go on for generations together. When you look at the prediction, you see the life of the project, like you look at the different stages of the project, like you look at the construction, you look at the operational, and also like how when do you decommission, all these stages you look at what kind of impact will happen, and then you predict, you make prediction for all of those. So you will also look at the rate of change of impact. So you will not just look at the impact, but because that impact means there's going to be some kind of change. So you will also going to look at the rate of change of impact. So how fast that change is going to happen. Will it happen in due course of time, slowly, or it will be a rapid change? And most often rapid change are not acceptable, something happening very rapidly. So you have to take care of those things and try to find out what kind of problems can occur. And then you would also look at the reversibility or irreversibility of a particular impact. So we had discussed these kinds of impacts before also. And then you would also look at whether the impact would be cumulative in nature, whether it will keep on adding eventually. So those all things have to be checked here. So when the impact is slow build up in an impact may be more acceptable. Like if the impact changes happen in a slow manner, it's much more acceptable than the rapid change. So in the example, you can see the farmland in the left transformed into residential uses right after the road expansion. So you can see how that has been done, and here you can see that these sometime because of the tourism or any kind of thing, a lot of things drastically change. So some of the changes where the changes are very rapid, those things are not acceptable. So that is what we saw about how, like, the different dimensions of prediction. And there's another term which we would like to get little clarification on. So when we look at prediction, we also look at the magnitude of the prediction and also the significance of the impact which we are looking at. So in this figure you can see that on this graph you can see the vertical line which shows the magnitude, probability, and reversibility and so on, nature of the effect, and on the x-axis you can look at the sensitivity value and the importance which you align to that. So whenever impact is seen, whether the impact is negligible or low or medium or high, it will depend on the sensitivity of the receiving component. So if the receiving component, irrespective of the low effect, if the sensitivity is very less, then it would be very high. The significance would be very high. And even if the impact is very high in terms of magnitude, probability, or reversibility, but if the importance assigned to that particular impact is very less, then also you would not really consider it to be significant, and you would still allow those kind of changes. So that's the difference between magnitude and significance. So irrespective how big the impact is, but if it is acceptable in terms of who is the recipient, or what value they assign to it, or how important that factor is for that particular context, based on that you decide the significance or the importance of that particular change. So you see that how prediction can be both subjective and objective process. So you see that irrespective like how scientifically you have made those calculations and determine the impact, the other component, how much important or significant it is, would be more of a subjective concern, or will depend a lot on the context which we are dealing with. Another thing which you would really like to clarify here is whether your prediction should be quantitative or qualitative. So it will all depend when you're doing the prediction. It will depend on the indicators, what kind of indicators you're dealing with. For example, when you are dealing with like air quality change, then it's a lot of data is readily available, and there are standards and guidelines. So a quantitative approach is preferred for that. And then when you're dealing with certain kind of social survey where you're looking at the satisfaction level, then it would be there's no way really you can do the quantification of it, so it will be qualitative. And then other example could be when you're doing a visual assessment, you're looking at the visual impact, then the kind nature of your prediction would be qualitative. So you, depending on what indicator you're picking up, you have to choose between those methods. And it is desirable that whenever you determine the impacts, you take it in units. It's better to have numbers, and when you have numbers, it provides a very good foundation, considerable strong foundation for evaluation, and that allows you to compare it with other localities, nationalities, and you can compare it with the international standards as well. So you also need to take care of probability while predicting. So what are the chances that the predicted impact will happen? So what are the chances of that? So you're predicting something, but then there is certain level of uncertainty in the technique you're using or what kind of data you're using. And so there's like, you also need to express that and be aware of that and communicate that. So now, looking at how to predict, we shall look at the methods and models for prediction. Here we are looking at the umbrella level. Prediction models are constructed on theories like how the environment functions and how factors influence and interact. So most of the time when you are predicting, you are using a prediction models. Most of them will be based on certain theories, scientific theories on how things work, how the air moves, how air pollution happens, and all those things. So it will be based on certain theories. So you need to know, or the persons whom you assign the task to should know about those theories. So these models will be based on such kind of theories. So you find mathematical and computer-based models. What do you see in mathematical models? In mathematical models, you represent the behavior of the aspect, like how that particular aspect is going to behave of the environment through the use of mathematical functions. So whatever theory you have, it is translated into a formula, mathematical function, and then based on that, the model is created. So you would select them based on the scientific knowledge available and what is really used in practice in your context. You may also put in statistical analysis, or you may undertake combination of both and use computer for the purpose. So you see that model can have various range. You can have simple or a complex and dynamic mathematical models. Mathematical models can be like also spatially segregated, like you can have you can do group wise, and you can also average them out and look at various factors together in an aggregated manner and also segmented manner. And then you can also have very location specific models as well, which would predict what kind of local change, net change would happen in that particular study area. So mathematical models can also be divided into deterministic and stochastic models. So you can have both these types. So looking at deterministic models, like you have the gravity model that are based on the fixed relationship. So you only the relationship is there, you put the parameters and it really tells you what's going to happen. And then the stochastic models, which are also the statistical model or the probability models, they tell you with certain degree of uncertainty. So what are the chances of this going to happen, and what level of uncertainties which are there. So looking at the example of deterministic mathematical model, you have socioeconomic impact predictor. Here you can see you see here change in level of income with J indicating the how much money is invested into an economy, and then you see the at various level like local, regional or national level, and how that increased the income in the economy by some multiple of the original investment which has been made. You can see the example here. So when you look at this, you can modify these models or even use them independently for each subdomain you see. Like you can see for each activity what kind of employment will be generated. So like during the construction time, what kind of employment would be generated during its running time, what kind of employment would be generated, and so on. And you can also look into various other segments also. So you can modify those models as well. So taking from the example, in this example from the interstate low country corridor west, you can see the EIA report here, and you can see how they have for the air pollution, how they have used the model here. So you can see all the equations, equation 3, equation 4, and all these equations are there. So average plume height, release height, and initial vertical dimensions, so how they are using the formula to make the prediction. So when you look at the statistical model, you have regression model, you have principal component analysis, so which you can describe the relationship between data, and then you can also test hypothesis, and you can also extrapolate data. So you can also find a lot of sophisticated representation, and then you can also use like fly through or walk through computer graphics, where you can really show how your proposed project would come, and then how in different scenario how the environment would change, and what kind of land use might change, what kind of visual impact would happen, how the air pollution would happen, but to what extent it would happen. So you can use all those kind of sophisticated representations as well. Further, you see you also have expert judgments and analog models. So in the expert judgments, you take inputs from the experts, and then you make judgments there. Such judgments can make use of some of the other predictive methods. So you can use cause-effect network or flow charts. Those can be used, like what impact would it have on the other, and so on. And you also have certain software related with that for the expert judgment purpose. The expert judgment can also draw on the analogous model. Analogous means something very similar, where you are recreating those environment. So from the analogous model also expert judgment can be made. So these models include comparing the impacts of a proposed development with a similar existing development, comparing the environmental conditions at one site with those of a similar site. So you have a reference, like what happened at that particular site. So based on that similar situation, what do you expect having the similar situation in yours, how that impact is quite possible to happen in your place as well. So analog models can be developed from site visits, literature searches, or also by monitoring, reviewing, undertaking case studies from the similar kind of projects. And then all nature of secondary data and case studies are all available. And then there's a range of other studies, EIA studies, which are available, so which can also be used as references. So we also see other kind of prediction model, like you also see GIS based environmental modeling, so where you can have the spatial depiction as well as all the attributes can be taken care of, and you can integrate GIS with other kinds of models, and all the variables can be integrated. The statistical and algorithm mathematical models all can be integrated with the GIS model, and you can do buffer analysis, over analysis, all this. So those were some overall methods which one can use for impact prediction, and all of these would vary from domain to domain. So how do you really choose among these, like which prediction method you are going to use and adopt in your particular case? So your choices depend on impact of which you're going to consider. So it will depend on the domain in which what you have to predict, and then you have to look at the types of impact prediction. And like you might also have there are certain categories which are identified, like you have hard model, where mathematical simulation models play a central role. So there are aspects where hard modeling can be done and mathematical simulations can be used. So for example, as we had already seen, air and noise impact, so mathematical models are available. So for that it's very readily available, so you would be asked, depending on the nature of the project, you would be required to undertake the mathematical simulations for that. And we see that the Gaussian dispersion models are there, so which we'll also see when we look at the air domain later. Then you also have soft model, where the use of mathematical simulation modeling is like there are no models. For example, you can see cultural resource assessment. So the subject type, you really don't find mathematical simulations in these. So here you use mapping and inventories and perception studies. You can use the photo montages, like where you can compare one photograph over the actual scenario, projected scenario over the existing scenario, and communicate it through pictures. So photo montage can be used, and you can also use GIS to indicate, understand the prediction, and then to communicate the prediction. So for example, you can see the cases here, how photographs have been used, maps have been used to communicate what kind of changes. So there's no mathematical model involved, but taking help of more of maps and pictures. So here also you can see the photo montage. It shows like how the proposed landscape would change. In the image you can see the existing landscape, and then how the proposed activity would change the landscape. Likewise in the other image also you can see what kind of visual image will be created when the project comes. So you can see here. So if we try to just explain what is photomontage is the superimposition of an image onto the photograph in order to create a realistic representation of how the proposed structure will appear in the landscape. So you take series of photographs of the area, and then you superimpose it with the proposed development and digitally edit and show like how the visual thing will eventually look with the proposal. So you also find mixed model, so where you use simulation modeling with other technically low level approaches. So you can use combination of things, like you can have traffic impact can be studied with modeling, and but it can be supported with the sample survey. and other kind of visual surveys, and then same can go with the socioeconomic impact studies and so on. So when you choose the prediction methods, you need to take care that how appropriate it is for the task. So if you have less time, if you have less resources, and if you have people, you don't have people who can undertake that, and the time is a constraint, and then even the legislation doesn't require it, so this you might not decide to go for that particular choice of method, which might be expensive and time consuming. You choose all these methods based on what kind of output is required, what kind of impact has to be undertaken, what geographical area you're dealing with, and what kind of different stages you will have in the assessment, what resource you have, how much time you have, what kind of data is available. Many times data might be not available to undertake those kind of mathematical models, and then what kind of expertise you have to undertake that. So depending on that you would choose, and then whether it is replicable or not, and whether your team can adapt to those things or not. So based on that you decide. So in many cases more than one method is suggested. It can be appropriate. For instance, range of methods available for predicting impact on our air quality is like seen in many of the cases. So in this example you can see a range of methods for you can have for the air quality impact. So you see pollutant emissions, atmospheric interaction, degraded air quality effects on receptors. So for all that you have range of methods. So you can have to identify the sources, you can have original project design. Then for pollutant emissions you can use the published emission data, emission factor models, emission standards, Gaussian dispersion models. You can use it for atmospheric interaction. Then you can degraded air quality. For that you can use wind tunnel model, water analog simulation model, expert opinion. And then for the effects on the receptor you can have laboratory or the field experiment methods, and then you can have inventories and dose response factors. So those things you can undertake. And then you see a lot of formal methods have been used in many of the cases. And then there are much more complex methods, but it's not important to use the complex method. So you see here we also find causal network in EIA production. So causal network diagram that demonstrate causal relationship between their elements that can be used, and it helps you to identify what kind of impact will happen. Here you can see how a housing project will have impact on the positive impact on the available housing, then how it will have negative impact on the adjacent stream quality, and how it might have negative impact on the aesthetic aspect of the area, and then how it will have positive impact on the population, and then how it will have positive impact on the traffic and noise. So you can see this diagram, causal diagram here. So that also helps you to identify various kind of thing. Then you can also see cause effect flow diagram here. Here you can see how this power station development and how that one would lead to the another, like what kind of impact will happen on the expenditure on goods and services. On the other side you can see labor requirement, peak total and traders, and then you can see how one connects to the other. Those kind of things can be seen here. So now looking at the uncertainty in the EIA process, like how do we really handle that uncertainty? So uncertainty is bound to happen in an EIA process and has to be mentioned. So there are certain uncertainties which you might see and they come from the accuracy of prediction, what kind of prediction methods have been used. So you any kind of work when you're doing, even if you are not doing the prediction but your team is doing, then you based on what kind of prediction they're using and what kind of accuracy that prediction provides, based on that you can make a judgment about the certainty with which they would claim certain things would happen. And then it would also depend on the kind of data they are putting in, what kind of consistency or inaccuracy which is there. If there's incomplete information, then also the prediction model, prediction which has been done, there would be a larger level of uncertainty in that. So you see a range of uncertainties. So uncertainties about the working environments, like in which the research is done. Then the uncertainties about the guiding values, like under which guidance you are working. And then there is uncertainty about the decisions, how things are being made. So these majorly, or from all these things also uncertainties come. And the lowest uncertainty is usually seen in the project screening, because you are using the list system and other things, and then there the lowest uncertainty happens. So how do you really handle all these uncertainties? So there are various ways to cope with uncertainties. So you can have structured involvement of the stakeholders, and then agreeing on actions and options based on the like what is the robustness of the project, how various factors are considered. So when you take all those factors and you take actions on those, then it reduces the uncertainty. And how all these impact, like you would be doing impact for various domains, so how those interact with each other, and how you are synthesizing it and taking out the information, so that all reduces the uncertainty. And then also undertaking sensitivity analysis, and then also comparing, also giving comprehensive and like very responsively monitoring the project. So that all allows you to handle the uncertainty. So when you provide confidence range, so you have certain level of confidence for the actual outcome. So that is also given by percentage which you handle. So now looking at the data sources for forecasting. So you can have some current data for forecasting. So you have key international and UK sources which are briefly mentioned here. So you can see here World Economic Forum, which provides information. You have United Nations Environmental Programme. Then you have Organization for Economic Cooperation and Development. So they also provide the information. Then you have World Business Council for Sustainable Development, as well as you have Intergovernmental Panel on Climate Change that also provides you data and guidance on undertaking it. Then you have European Agency, European Environment Agency, that also provides you guidance. And then Department for Food and Rural Affairs, DEFRA, also provides you information, as well as you see Department for Business and Energy and Industrial Strategy also provides, and then Natural England Environmental Agency. So all of these are there for your guidance here. So now looking at the evaluation and assessing the significance. So you see that here you have sensitivity of the receptor on the one side, and then you see the magnitude of the impact. So depending on what is the sensitivity of the receptor and then what magnitude of the impact is there. So even if the receptor has the higher holding capacity, so the or less value is assigned, then a high magnitude impact can also be taken and would be less significant in that case. So that all there's all framework given to that, the detail of which we'll see in the next session. So summarizing what we covered today, we looked at the dimensions of prediction, then like what all really you take care when you considered prediction. Then we looked at the umbrella methods and models used for prediction. And then we looked at the component of uncertainty and EIA prediction, and then we looked at various sources of data for forecasting. So that was all the coverage for this particular session, and these are the key references which we used for this particular session, and these are the suggested watch and read. Please feel free to ask questions. Let us know about any concerns you have. Do share your opinions, experiences, and suggestions. Looking forward to interacting and co-learning with you while exploring AI. Thank you.